Welcome to the Walton Pi. Today we're going to talk about what it means for something to be a binary operation. So, a binary operation is any operation that takes two inputs and gives us out a single output. So, a more mathematically rigorous definition is a binary operation on a set S is a map from S cross S to S. If you're confused, let's talk about some examples, okay? So some basic examples that you've probably seen before are the common arithmetic operations. For example, addition combines two elements to give a single output. So we combine 12 and 8 and we get 20. Here, the inputs are 12 and 8 and their output is 20. So I take in two numbers and I spit out one number. Okay? Addition, that's an example of a commutative binary operation. This means that the order of the two inputs doesn't matter. I can do 12 plus 8, or I can do 8 plus 12, and I'm always going to get out 20. Okay? Other binary operations are not always commutative. For example, the operation of subtraction is a non-commutative binary operation. We have 12 minus 8, that gives me 4, but 8 minus 12, that gives me negative 4. 4 and negative 4 are different, so that means that this is a non-commutative binary operation. It still takes in two inputs, 12, 8, or 8 and 12, but it gives out different outputs, depending on which order the inputs came in. So if the order matters, it's non-commutative, but if the order doesn't matter, it's going to be commutative. So, if not every pair of elements in S cross S maps to an element in S, then we say that the operation is a partial binary operation. So binary means every pair needs to correspond to an output. So for example, division, that's a partial binary operation. Since a divided by 0 is not going to be defined for any number a. It still is an operation. It still helps us be able to combine things. It still takes in things, but it's not always going to give us out something that makes sense. For example, if 0 is the second thing, it doesn't make sense. So of the four basic arithmetic operations, only division's a partial binary operation. Addition, subtraction, multiplication, every pair of numbers is going to work. Okay? So all of those are just regular binary operations, whereas division is a partial binary operation. So let's talk about some other examples of binary operations. We have function composition. So this doesn't deal with numbers. So if we have a function from d to d, then composing those functions is going to be an example of a binary operation. Matrix addition. We can add things that aren't numbers. For example, matrices. We can do matrix multiplication as long as all the matrices are square. If they're not square, then we're not dealing with the same set because you need square matrices to multiply this from the same set to be able to multiply. Exponentiation. For example, 3 to the 6, I can do that. That's combining the number 3 and the number 6, and I get out a number, which I believe is 729. So exponentiation, that's an example of a binary operation. And there's so many more. I can't list them all. It's too many. But I hope this cleared up what it means for something to be a binary operation. Please check out some of my other videos, and if this one was helpful, please like and subscribe. It really helps me out to be able to keep making these videos. And if there's a different math concept you want me to cover, leave it as a comment down in the comment section down below. I hope you have a great rest of your day, and good luck with all of your math.